All right, so we're going to take a quick review of simplifying expressions using the properties of exponents. So we're looking at when do we add our exponents, when do we multiply them, and when do we subtract them. So if we look at this first one here, we could see that we have x to the second times x to the fifth. Now keep in mind this is an exponential notation, and if you need to, if you forget your rules, you could always go back and say, well, x to the second is x times x, and x to the fifth is x times x times x times x times x. And then you would see that if you have the 2 here and the 5x's here, you would have x to the seventh. And then the shortcut that we're looking to be able to use so that we don't have to write out all those x's all the time would be to take and just simply add those two exponents. If we look at something like this, we can see we now have coefficients. Remember, coefficients are the 2 and the 3. And then remember that what we're actually doing here is a multiplication problem. And so we treat those coefficients like we always do. We're just going to do multiplication. So we're taking 2 times 3, which would be 6. And then if we look at our bases in x, so we have like bases, and we have x to the third. You can visualize there'd be 3 x's there, and x to the seventh, there would be 7 x's there, and so that means that altogether we would have 10. So our simplified expression would be 6x to the 10th. In this problem, you could see we not only have coefficients, but we have different variables, different bases. And so I'm going to take my coefficients first. Negative 2 times 3 is negative 6. Then I'm going to look at my x's. I have an x to the first and an x to the second. So 1x here and 2 here. That's x to the third. And then my y's, I have y to the third, 3 y's. And I have y to the third, 3 y's, and that's y to the sixth. Now keep in mind that this same problem can be written with either the dot in there to show multiplication, which is what it has now, or can be written with parentheses around it to show multiplication. This would be exactly the same problem. And if we can look at this here, we want to keep in mind that it's the same thing, same property, if our base is not a variable, if it is a constant. So what we would really have here is 3 to the second, 3 times 3, and 3 to the fifth, 3 times 3 times 3 times 3 times 3. And if we simplify that, that would be 3 to the seventh. And a common mistake here is sometimes, it looks easier when we do this problem. Students will automatically know that that's x to the seventh. But if we take and we put in place of this x, we put a number in like 3 over here, they want to take and multiply that together and get an answer like 9 to the seventh. So, but if you think about going back and doing that expanded notation, you can see that you don't multiply those bases, that the correct answer is 3 to the seventh. All right, if we look at our next type of problem, here we start to look at when we're going to multiply exponents. And so if we look at what we actually have here is x to the second 3 times. So this is x to the second times x to the second times x to the second. And then we just talked about each one of those x to the seconds is 2 x's. And so what we really have here is x to the sixth And so our shortcut here, when we have an exponent to an exponent, or what we call a power to a power, is to multiply those exponents. When we have more than one base inside of parentheses, we still need to use that exponent with everything inside the parentheses. So if I write this out, what I have here is 3 to the second power, and then I have x to the second power, and then y to the first to the second power. And so my coefficient 3 squared would be 9. X to the second power would be x to the fourth when I multiply those exponents. And y to the first to the second power would be y to the second. If we look at our next problem here, if we forget what to do when we are dividing like bases with exponents, if we wrote out our x to the fifth in expanded notation and our x to the second in expanded notation, we could see that this x would cancel out and this x would cancel out. And what I would be left with is x to the third. And what the shortcut is here is to subtract these two exponents. My next example has a coefficient with it. And remember that coefficients do not have special rules. We follow the same thing that we always have with them. So we take our 10 and divide it by 2, and that'll give us a 5. And if we have x to the fourth over x to the first, that would give us x to the third. And we can expand this property and look at when we have this one. We have a coefficient, we have x variables, and we have y variables. So we just take it one piece at a time. So divide here, that's going to give me a -5. If I look at my x variables, I have x to the fifth over x to the first, which will give me x to the fourth. And then if I look at my y variables, I have y to the third over y to the third, which is the exact same thing in the numerator and the denominator. We're just going to cancel each other out. So my final answer would be -5 x to the fourth.